due process. So give me a minute to bring up that video we did last week. Give me a second there. It should be. Well, then I'll get exactly that one. Okay, remember this animation we kind of went through? We did all the pregnancies. We got the baby out. So we have one more little bunch of hormones to work on, which is now you've given birth. We do have to worry about making the milk for the little guy, right? You're a mammal. So we're going to spend a little bit of time focusing on these things. Let's learn about mammary gland.
A complex interaction of pregnancy hormones signals the development of breast tissue in preparation for breastfeeding the expected infant.
Yes, indeed.
The amount of the hormone prolactin, essential to the initiation of lactation, increases steadily throughout pregnancy. However, high levels of both estrogen and progesterone during pregnancy inhibit the action of prolactin on mammary tissue, so no milk production occurs. After.
So, what do you pretty much complain about your mammary glands?
There's soreness.
Soreness, engorgement, you may hear people say, because you're making all this milk that's not really going to be released. You're not really going to, you're enlarging the tissues, you're not really making the milk and getting the milk out of there. So you have this problem where they're away from the door all the time. But then you're going to get birth.
Levels of estrogen and progesterone drop, and inhibition of prolactin action on the mammary glands ends.
So you're making milk over that lactogen thing. You're getting the breast ready for milk. They're starting to get more and more production. They have a baby, no baby born, so you don't release the milk until later. So now we're going to give birth. Click on prolactin.
After parturition, the primary stimulus for the production of prolactin is the sucking action of the baby. Stretch receptors in the breast send nerve impulses to the hypothalamus. The impulses inhibit a prolactin-inhibiting hormone, PIH, and stimulate a prolactin-releasing hormone.
All right, so if we read that again, I'm going to turn off the turning offer. All right, I'm going to stop stopping, disinhibition, and turn on. So what do you think the prolactin-releasing hormone would cause you to make if that's turned on? More prolactin. What's prolactin ready to do? Make more milk. So the idea is I'm going to make more milk.
Triggers the release of prolactin from the anterior pituitary. Prolactin circulates to the alveoli of the mammary gland and promotes lactation.
I bet you there's a graph going on here. Let's start making a graph. How about we do over here? I know this graph. My sister had to do me. This graph works. Let's do milk production over time, or you can do milk amount over time. Pick a word you like. Okay, so we're going to have the baby. So we're going to be nursing here. So what's going to happen to the milk level in you when the baby's eating? It's going to start dropping, right? Baby's eating. So what does your anterior pituitary do if the milk production's going down? Because baby's eating all that milk. I'm going to release PRH, which is going to tell me to release more PRL. PRL tells me to do what? Make more milk. So then I'm going to turn around, I'm going to start making more milk to replace what the baby used, right, or took away.
What's the signal for the fact that the glands are empty? So how does PRH get released?
So basically what happens is the myoreceptors don't send impulses back to the eyes, and so they get the gist.
Okay.
Let's say you wean. Let's wean him. Hypothetically, the next day you wean, okay? What does your milk production do? It's way, way up. Because no one's drinking it, what would happen to these hormones? They're going to go down. The brain says, I don't want more milk. Therefore, I don't want more milk. And then slowly you dry up, as we say in cattle land. Like that. Okay? Weaning. You stop nursing. Wean. That's what's the whining. Make sense? So what kind of homeostasis is this? Negative feedback. So if you ask a dairy farmer, how do you make more milk in a cow? You simply milk it more often, right? The more the cow milks, the more the brain wants more milk to replace what the baby used. So if dairy farmers caught on and milk the cow 3 times a day, I get 3 times the milk. You go cold turkey one day and say, I'm going to stop nursing my child tomorrow morning. You're not going to feel good because your breasts are prepared to make milk and the baby's not taking it. So that's the engorgement, the soreness, all that stuff because you're overproducing for a baby that's not there. Right? It's drying up a cow.
Is there like a quality over quantity kind of thing?
Yeah, in theory. The later in night that you nurse, the more fat in the milk there is. So your mammary glands change the fat content of the milk depending on what time of day it is and how empty they are. So the more milk you drain, the more fat content there is to freeze the CCK in the baby so the baby sleeps longer.
Sorry, what does the PRL stand for?
Which one?
PRL, prolactin?
Prolactin releasing hormone. Sorry?
No, the PRL.
Prolactin.
Does prolactin is the PRL?
PRL.
Okay.
So in theory, the more your baby is drinking from you, the more milk your body should try to compensate and make more. Right? The less they drink, the less you make. Basic negative feedback. That's how you wean, right? All that stuff. So a wet nurse from history, right? You just never stop nursing. Your breasts keep making milk all the time because they think there's a baby there. Right? So the important thing to kind of think about is it's your brain that determines whether or not you make milk. This has nothing really to do with your uterus or the baby. It's simply your brain thinking somebody wants to drink. Right? Yes?
Isn't the, so like during pregnancy, estrogen, progesterone inhibit the milk release. But
Yes.
then what is it? Is it the sucking action of the infant that actually stimulates the prolactin production initially?
Yeah, technically it's the emptying of the breast. So as the baby sucks more milk out, the brain picks up the signal that I'm losing milk and therefore tries to pop the rate up. Yep. Yep. Make sense? Oh wait, there's more. Click on some cells.
Once milk is formed, it is ejected or let down by the action of the hypothalamic hormone, oxytocin. The primary stimulus for oxytocin production is the sucking action of the baby. Stretch receptors in the breast send nerve impulses to the hypothalamus. The impulses stimulate the production of oxytocin. Oxytocin circulates to the myoepithelial cells surrounding the alveoli of the mammary gland, which contract and force the milk out of the alveoli into the ducts where it can be suckled.
So, there's another hormone here. What's the other hormone we need to nurse? Oxytocin. So we'll write both those hormones over here. So remind me again of the job of prolactin. The first hormone. What's to do what? That's basically make the milk production. And the oxytocin to release the milk, let down the milk, squirt the milk. There's lots of words you can say. But both of those have to work for me to make the milk and release it to the baby. So again, if you have dairy animals, you rub their udder, their brain thinks the baby's latching on and starts squirting the milk down the teats to the milking machine because their brain thinks it's time to release the milk. That's why you do that. Make sense?
So crying tricks the hypothalamus to thinking that you...
Yes. So in addition to physical stimulation, anytime it's nurse time, the brain thinks, oh, there must be a baby soon, I'll start letting the milk down. That's why nursing women will let their milk down in the laundromat, hearing a baby cry, it's 5 o'clock, all those things, because the brain is what's controlling when you make the milk and when you release it. So you don't have to actually have a baby per se. So as adopted parents, you can play games with this one. You can actually get drugs as an adopted mom that will tell your brain and sort of charge it up as though you've been pregnant, and then you can breastfeed without ever giving birth to the child. Because the brain is what controls the milk, not the baby. Right? You have to teach the brain that you want to nurse. Yeah.
You wouldn't get colostrum from that, though, would you?
Usually not. Usually you can, but the problem is that the volume is so low. But usually you don't get that huge, but you will get milk eventually.
Is it okay? What is it?
It's called, sounds silly, it's called Don Peridone. Sounds like a champagne, right? What it is a huge surge of a, what is it? I'm trying to remember which specific hormone it is. It escapes me right now, but there's a huge surge on the hypothalamus. The hypothalamus immediately thinks you've been pregnant. And then you have to couple that with pumping. So you have to buy a breast pump or nipple clamps or something and put them on. And then your breasts are getting the signal that there's a baby there all the time. Your brain now thinks you're pregnant, and the two come together and say, I guess I need a nurse. And then immediately the brain turns on the memory system without actually being pregnant. It's easier if you were pregnant, but you can do it without being pregnant.
Is there any side effects from that?
Not that anyone's noticed.
There's another women who aren't producing enough breast. They give it to women who aren't producing enough breast.
Right.
It's not just, don't they give people fenugreek or whatever?
Yeah, an herbal one with fenugreek was known as a way of doing it, yeah.
Isn't another pill too that's off label?
I can't remember either. No, there's other ways. But domperidone is the formal one you get. So we get our oxytocin and prolactin. So those are the dairy industry and or making babies milk. Those are two hormones we didn't cover last week. That makes sense? That's the only new material today.
Really?
That means you're done with 233 in terms of new material.
Oh, wow.
Right. So that means now we can put the whole year together. So we're going to do a little bit of some capstone experiences, which means we'll be using a little bit of our packet of pain. Before we do packet of pain, I'm going to give you something that is not your packet of pain. Why? Because I'm just that way. I'm going to show you some pictures of real patient data, and you and your future colleagues in the nursing business are going to interpret this data. Based upon
From the whole year.
from the whole year. So let me show you the data. I'll show you what's going on here. So, as nursing professionals, you will quickly see a lot of these popping in your job. This is me, right there, right? This was the last time I had some blood work done and some pee work done. That was a long time ago, right? So, you will have these in front of you when you talk to your patients. And so, being good nursing professionals, you did 232, 233, 231. A lot of these things just start making some sense to you now, right? If I've done my job, you understand the meaning of these lines and what they're for. So, for example, I see a GFR value, right? I see sodium, I see albumin, I see vitamins, I see TSH, I see all these things you've learned. Okay? So what you're going to do is interpret my blood work for me. Okay? I'm okay. Things like that. And you're going to answer some questions. I'm printing out for teams. So I'm going to each one to a table. And you and your table are going to try figuring out some things about this blood metabolic panel. And we're going to go through as a class, see how much of this chemistry you remember. Am I a dead man? Yeah, okay, I'm a dead man. Right. So we'll do the first one together since you can't see the whole thing. So the way this is written is, this is the normal over here on the right, this reference. Anything that's in the doors is out of range, that's the bad number. So scream when you see something out of range. What do you see? My bilirubin is high. Yes, indeed.
Are you 46?
I am now, yes. I'll be 46 in a couple days. What year is this anyway? 215? Yeah. I don't know. I gave up counting when I was like 20 something. Right, so I have high bilirubin. Okay, let's go to the next page, which is this one here. Okay, here, right? So the only thing wrong with me on this label is that my bilirubin's high. So we got to figure out what that means. What does that mean in my high
Liver problem. That's
right. Liver problem is what I do.
You have liver
I was going to block bile.
It's not Diet Coke. No, you haven't today.
Unfortunately for you.
You have cirrhosis.
I have cirrhosis.
Block bile. Wake on
Not as
RBC.
much, and I will block bile there.
Wake on RBC.
Yeah. I actually have.
Gilbert's disease.
What's your name?
Yeah.
That's not
It looks like Gilbert, right? Okay, so what this means enzyme in my liver that should be breaking the bilirubin down more faster. My enzyme is slow. So bilirubin builds up in my body because I can't break it down as quickly as I'm producing it. So it overspills into my bloodstream. So it's always a little bit higher than the normal, which is not by much. Right? But that's good that you caught that. So I have bilirubin. If you didn't know that, you'd say, hey, that's wrong because it's a liver somehow problem getting rid of my blood vessels. Blood vessels, blood cells.
Does the H mean high?
High. Yeah. So on your list you're going to get in nursing school, you want to start looking for those things that flag, oh, that's not good to have bilirubin. So there should be a reason. And you name all the bad ones, right? I'm a drunk. Got 4 kids on a farm, I'm going to be drinking too. But that means there's some problem in my liver, biliary system to flush the old RBCs out that you learned in 232. Yes.
Are we getting more P for this activity?
Yes.
Okay.
Yes. So let's go down to number 2. We're going to look at my HDL-LDL relation, which is at the very top. So someone tell me what those are representing. Cholesterol. So from 232, what's so bad about cholesterol?
Close your arteries.
Clogs up your arteries, right? I mean, it plugs the pipes. And what's wrong with plugging my arteries?
Low blood pressure.
Blood pressure screw up, right? I don't
High
get
blood pressure.
perfusion.
You gotta break off.
Things break off and plug things, right?
Right.
Wrecks my kidneys, all those bad things. So you have to remember the difference between HDLs and LDLs. So HDL and LDL, there's a difference. Which of those is the good one?
HDL.
No,
HDL is the good cholesterol, and LDL is bad. What makes it good and bad?
The type.
Density, but what physically in your body makes it good or bad? Okay, HDL removes cholesterol. So if you have HDLs, that means it's going to take it off the blood vessels and flush it. LDLs want to stick to your vessels. So they're both cholesterol, but the HDL is not sticky, the LDL is.
Does HDL attempt to remove the LD?
Yes, basically HDL is trying to remove LDLs.
How do you get one or the other?
Diet mostly.
avocado or steak?
Kind of. So HDL is found primarily in plant-based oils, so that's the liquid fat. LDL is going to be found in solid,
Like bacon.
like bacon. So this room temperature solid is an LDL, room temperature liquid is an HDL. And then the ratio between those is partly genetic and also partly diet. So let's look at my ratio, blah, 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 blah. So if we calculate my ratio, it should be right here. Right? This would be 0.9, 0.5, 5.3, and they didn't actually do
Where do
the
you
ratio,
see-
did they?
Where do you see the number?
It's after that.
2.4.
Oh, there it is. So 2.4. So is that okay? To have a 2.4 if the range is 0.9 to 5.3?
Yeah.
Yes, that means I have an okay ratio between my good and my bad.
Sorry, what was the range?
That's 0.9 to 5.3. So in English, that means I have enough good cholesterol to keep the bad cholesterol from sticking around. Right? So if I decide to eat a bunch of bad fat, then I can make the ratio go the wrong way. That's the ratio you're going to be looking at your patients to see if their cholesterol matter. So by taking a statin drug, that's what they're trying to adjust for statin, is that ratio.
Did you fast before?
I think I had to, yeah. It's been so long, I don't know, when was this? It was like
Years ago.
42. 2011.
2011, I have no idea what I did 2011, but I'm pretty sure I had to fast. Right?
Where does it say that?
Somewhere. Fasting.
Oh.
So let's do the other ones. Glucose. So what is glucose measuring?
Sugar.
Sugar. So let's see, 85, reference range is 65 to 99. Is that okay?
Nice.
That's fine, right? It's not too bad.
Pretty high.
So if I'm not eating and my sugar is really, really high, then I'm diabetic, which I'm.
Must have been all those Reese's peanut butter
That's
cups.
what those just paper cups to drive into the doctor, right? Right. So okay, let's do my bun. So this means urea nitrogen in my urine. So how much nitrogen is in my urine? I call it bunning. Right, 17, range is up to 25. That's okay, but what would that mean? Where's that nitrogen coming from?
Bacteria.
It could be bacteria. That's usually nitrate, not this.
Cellular waste.
Nitrogenous waste, which I get from doing what?
Working out.
Breaking down protein, right? So it's measuring how much protein my body is digesting. So as I burn more protein, the bun level begins to climb because I'm peeing more urea out. Does that make sense? Sort of an inaccurate measure of how much protein you're burning is your bun. Right? It has other factors that come in there, but that's basically your urea you're measuring. So creatinine, you remember that from 231. What's creatine? Muscles. Creatinine is the waste product of that. So by measuring my creatinine, they measure partially my muscle metabolism, which is normal. But also, it's a waste product. Where do you send all your waste? To your pee. So if you look at number 4, which metabolic panels can measure kidney function?
Creatine.
Creatine can, because I should urinate. How about the bun? Yes, because it's a waste product. How about glucose?
No.
It usually doesn't directly, but it could, right? Like kidneys aren't reabsorbing, that would also affect them. But the main ones the doctor's going to look at for your kidneys are these two. Because that's always in my pee, and that should spill over out of my urine, because it's the waste product I don't want. That's how they measure your GFR. Is they take those numbers and calculate how much pee I made, and calculate a GFR, which is the next question. My GFR! I'm a white guy, so I take the top line. My GFR was 107, which is actually okay. Right? It should be more than 60. Right? So then I can measure GFR. So what does GFR measure again? Filtration rate. That's measuring how much my kidney can clean per unit time. So that's how they're measuring GFRs. If I was black, it would actually be a different number. They calculate it differently because the muscle mass between blacks and whites differs enough. They calculate it differently. Believe it or not. Right? Makes sense. Yeah. So, let's do respiratory acidosis. Where would you go to find respiratory acidosis? What 2 numbers would you need? Carbon dioxide, which they're saying is 26. Okay, so that's kind of low, right? And I need pH, which I don't think they actually did my pH. But let's pretend. If my carbon dioxide is 26, that's going to be low. Carbon dioxide, which would make me what? Alkalotic, right? So I'd need respiratory alkalosis when I did this test. Why would I do that? Why would my CO2 be low? I was breathing too fast, I'm nervous, right? I didn't have my Coca-Cola. Okay. Only had 2 kids at the time, right? So if I'm breathing too fast before I go to the doctor, I'm going to blow away my acid. Respiratorily, it's going to mean respiratory alkalosis. Right? If I were a smoker, then that number would have climbed. Right? Make sense? Hematocrit. Let's find my hematocrit. Hematocrit, I think, is on that page. This one? Hematocrit. There it goes. 44%. Is that okay? See, last turn you learned what? 47 plus or minus 7? Right? That's okay. Right? So 40, that's normal. Right? Okay, so let's do my TSH. TSH, 0.7, got a huge range. What does TSH tell my body to do? It's T3 and T4. So if that's normal, that means I must be having normal level of T3 and T4, right? If that number were to climb, what would that be telling the doctor? I need more metabolism, so my brain's trying to make my thyroid speed up, right? Hypothyroidism. So that's the number to look at to see how much energy your cells are burning, is TSH, because your brain would try to order more or less over time. Makes sense? Yeah?
So if TSH was high, that would be like you're hypothyroid because the TSH is yelling at it and it's not doing it.
The implication is, yeah, your brain's yelling for metabolism, your body's not producing it, so we just yell more and more and more.
What about hyperthyroid? Would it be really low?
Then it'd be really low if it's caused by the thyroid. If it's something the pituitary, then that's it. So overall, what'd you think of me, health-wise? I'm dead, right? Right. But this is one of the skills you're going to get when you get to nursing school is can you read these data and sort of think about what does this mean in terms of what you learned this last year, right? What does creatine mean? So that's showing you the kind of skills you're supposed to be learning, right? Now let's do a real skill that matters in terms of your final exam. Get out your packet of pain. We have one more little thing to play with.
Why do you need vitamin D?
Why do I need vitamin D?
Okay, I didn't say it, because you vitamin D.
I always need vitamin D. Everyone should have vitamin D.
Yeah.
What page?
What page in the packet of pain?
Let me show you the page. Go to page 47. It's the one that says end of the year case study. This is something I've done the last several years, but this little case about rowing a boat has lots of things that you've learned in the last 3 terms, and some of them are stuff on your final this term. So what you're going to do with your team is you're going to read through this guy rowing his boat, right? And then on the back side, page 48, there's a series of questions for each step of his race. Start, minute, finish, race. What you're going to do is you're going to basically read it, and then answer these questions on the back. I'm going to give you about 10 minutes to do that, and then we're going to go around the class and see if you can answer these questions for me. And we'll talk about what you learned, and once they apply to this exam, we'll go through a little bit more. Make sense? And see if you can remember years with the A and P here. So give that a try. Find a friend, read a case, answer some questions.